Space debris is an issue because whenever a satellite is sent up, it has a life cycle, or it has a predetermined time at which it's going to be working for. Mostly it's due to fuel consumption. Some of them have to do some minor maneuvers to fix their orbit, and then once it reaches the end of its life, it basically becomes junk, and then they are transferred over to an orbit that's basically a bunch of space junk just rotating around the Earth. One of the issues with that is sometimes it hits working satellites and then make those working satellites become space junk themselves. The idea was to have a robot in orbit that would be able to start cleaning up some of the space debris issue that we have going around the Earth. Our design is Project Typhon. It's a continuation of last cycle of senior design Project Cerebus. Project Cerebus is a robot that's a lab prototype of a satellite. It's able to locate and track space debris, and it's able to get close to them and then perform minor repairs or even capture some of them. If Cerebus was doing its own mission and then ran out of fuel or charge, Cerebus itself would become a space debris. So in order to try and figure out how to handle that, our team for this cycle of the senior design project decided to do a mothership, which we called Project Typhon. The mothership would entail a rendezvous location or system or point, and so that a cluster of services would be coming in and out, being recharged and refueled. We focused on an interface between Typhon and Cerebus, which we called TRIX, the Typhon Refuel and Recharge Interface for Cerebus Capture System. Project Typhon with the TRIX, with the interface that has the two capture systems that they connect over with these guiding cones, and the clamps, they secure it in place and they retract. With the retraction, we connect our refuel portions, and that holds it in place. And after it's held in place, then we have our recharge portions connecting. After also it's held in place, then the refuel allows for a fuel transfer. Currently we're using cold gas, nitrogen. After both of them are filled up, then we have a mechanism that releases the refuel connection, and then the clamps will uncapture Cerebus, and then Cerebus will be able to go on its mission.
We actually use cameras and LiDAR sensors and proximity sensors, and these sensors feed to our graphical user interface and tell the pilot how close the robots are together. So when the pilot is able to see that they're close enough together, that's when they actually dock, so that nothing gets crashed into and everything's in the right orientation, so it can properly do its refueling and its recharging process. The pilot would guide Cerebus around in space to find the space debris and make repairs on it or capture it. And then when Cerebus needs to be recharged or refueled, it'll find its way back to Typhon, and that's when the recharge and refuel portion will happen. Project Cerebus kind of got the inspiration from Greek mythology. So Cerebus is actually like this three-headed dog creature. And they kind of chose that as the name because Cerebus has 3 arms and 3 thrusters. So they thought it was pretty fitting and resembled that. So when we started our project, we decided to name it Typhon. And Typhon is actually the mother in Greek mythology of Cerebus. So our mothership design kind of got incorporated into that with the name.